In this next section, we're going to take a closer look at the loadings and scores that are the other two major pieces of output that we get from principal components, aside from the eigenvalues. First of all, the scores are the new coordinates of the data in the basis of principal components. We'll use the fact that principal components are linear combinations of original variables with weights given by the loadings. Now, this has a geometric interpretation, but it's not always helpful. Sometimes it's easier just for students to think about the fact that principal components are algebraic linear combinations of variables with weights given by the loadings. So if I write V1 is the vector 0.7, 0.7, what I mean by that geometric interpretation is that the 0.7 tells me how far to go along the x-axis, and the other 0.7 tells me how far to go along, in this case, the x2 axis, in order to get to the unit vector V1 pointing in the direction of maximum variance. But more importantly, you should realize that the column of scores can be created just by taking a weighted sum of the two columns in your original spreadsheet. That's the other thing that this means. So the new column of data, which would be the scores, which again, this is hard to understand because I'm kind of insinuating that V1 is two things. V1 is the vector of loadings, but the vector of scores is the linear combination of the two columns from the spreadsheet. So let's kind of visualize that here. I have my original data. Of course, this is always after centering. I said always, always, always in this class, we're thinking of our data as being centered. Sometimes, if we're using the correlation matrix, our data will also be divided by the standard deviations or standardized. But for now, this is our centered data. I have two columns in a spreadsheet. And so if I multiply by the vector of loadings, what I'll get is a new variable. Now, because of all the analogies going on here, the terminology from the software can be confusing. In SAS, this new variable will be created in an output data set, as we'll see, and it will be entitled prin1 for principal component 1. And so that's the new variable. That's the coordinates of the data projected onto the direction of the first principal component. And we can do this for all the components at once, which amounts to matrix multiplication. We multiply our data matrix, either centered or standardized, by our matrix of eigenvectors, which are the loadings. And on the other side, we will get our new set of coordinates. You see this has the same length as my original data because I have one coordinate for every observation. In the loadings matrix, I have one coordinate for every variable. So I have 5 variables here. I have 5 loadings in each column. And so even when the terminology gets confusing, and I'll show you how it gets confusing, you can always figure out what you're looking at just by looking at the dimensions of the matrix, because loadings need an entry for every variable and scores need an entry for every observation. So again, there are 3 major pieces of output that we're going to be looking for. The first is the eigenvectors. These are the principal components, meaning the directions of those axes, also called the loadings, sometimes called the rotation matrix, because it involves a rotation of the elementary axis. These will be found in the output window in SAS. Another piece of output would be the eigenvalues. These are the variances of those new variables. Sometimes they're given as standard deviations. in which case they're the square roots of the eigenvalues. The third is the coordinates of our data in the new basis. This is often called the scores or the scored data. And this you'll create in an output data set in SAS. Now you'll notice on the slides, I'm only talking about SAS. We're gonna use R for a good portion of this analysis. And there are two R functions that are available for use, and I will introduce you to both of them.